Dear friends, welcome to our video in our YouTube channel. In this video, we shall be looking at the proof we have on screen, which is the proof that the limit as n goes to infinity of 1 plus a over n raised to the power bn is equal to e raised to the power ab, and we have the similar proof here right here. So guys, if you are new to this channel, don't forget to subscribe to the channel because that is the only way we are going to help you to pass your exams with very good grades. We can only do that once you have subscribed to the channel. Please, if at any point in time you found this video useful, please don't forget to press the like button beneath the video. That goes a long way to motivate the academy to keep producing more great content for you. Thank you very much, guys. Let's dive straight into the video today. Okay, friends, let's have the first proof, and once we must have been done with that, then we are now going to be looking at the sample assignment that was given for the National Higher Polytechnic Institute students for engineering mathematics. All right, let's look at it, which the limit as n goes to infinity of 1 plus a over x raised to the power bx. So guys, in this case, we are going to let our y to be same like the limit as x goes to infinity for 1 plus a over x raised to the power bx. In this case, guys, if we take the natural log on both sides, we're going to have ln y to be same like the limit of as x goes to infinity of the natural log of the function. Keep in mind that the limit function, friends, it is a very considerate function in such a way that any function, any extra function you take it into, the limit can go outside conveniently. So we have the limit as x goes to infinity of the natural log of 1 plus a over x raised to the power bx. In this case, guys, we are going to apply the log property that tells us that we can bring the power of this guy, we can bring the power to the front. If we do that, we are going to have the natural log of y equals the limit as x goes to infinity of bx comes in form. We have bx, the natural log of 1 plus a over x squared. So at this point in time, friends, all we have to do at this point is to apply L'Hopital's rule, but we cannot apply L'Hopital's rule until we have the quotients of two functions. But there's a way in which we can arrange this part in such a way that we have a quotient, right? So we are going to send bx down, okay? We'll send bx down. So it's going to go now as natural log of y equals the limit as x goes to infinity of the natural log of 1 plus a over x, all that divided by now 1 over bx. Keep in mind that if you multiply here by 1 by bx, here by bx, we have the same function. So this is what we have at this point. Now, since we have the product, the quotients of two functions, we can apply L'Hopital's rule. L'Hopital's rule is simply saying that we should differentiate the top and differentiate the bottom before putting the limit. So friends, if you differentiate the bottom and the top, we are definitely going to have the natural log of y equals the limit as x goes to infinity. Differentiating a natural log function means we are just going to have the function, the interior of the function, that is 1 plus a over x. Then now, guys, what we put at the top is simply going to be the derivative of the inside. The derivative of 1 is 0. Derivative of a over x is simply negative a over x squared. Then differentiate the bottom. 1 over b is a constant. Differentiating 1 over x, we are going to have negative 1 over x squared. So we have the 1 over b multiplying it. So in this case, guys, if you multiply top and bottom by negative bx squared, we are going to have this. Simplifying the whole result, guys, you notice that this will cancel this, right? Negative bx squared will cancel negative bx squared. We have negative cancelling, x squared and x squared cancel. So if we do that, we are going to have our natural log of y to be like the limit as x goes to infinity of, we have ab over 1 plus a over x squared. So guys, you notice that whenever x goes to infinity, a over x simply dies down to 0, right? Because the bottom is heavier than the top. When x becomes so large, this guy simply goes to 0. So in essence, we are going to just have the natural log of y being equal to 1 plus 0 is 1. So we are going to have ab. So we have ln y to be same like ab. At this point, to solve for y, we simply take e to the power on both sides. We are going to have y to be same like e raised to the power ab. Keep in mind that e raised to the power ln y is y, okay? E raised to the power ln anything is just that thing. So we have y to be same like e raised to the power ab. But guys, what is our y? Our y is what the limit as x goes to infinity of 1 plus a over x raised to the power bx, right? So in this case, we are going to have that the limit as x goes to infinity of 1 plus a over x raised to the power bx is the same like e raised to the power ab. Okay, now guys, this is the proof. This is the proof. There are a number of ways in which you can do this. You might not necessarily need to do calculus. You might not necessarily need to pass through L'Hopital's rule. You can still do some substitution here, okay? And it is going to serve the task for you. You could still use a power series, okay? Because at this point we have the natural log of 1 plus a over x. We could use the power series of natural log of 1 plus x, okay? Because our x in this case is a over x, we can substitute it, guys. We'll still have the same result. Okay, so let's look at the example that was given for the engineering students. They want them to evaluate the limit as n goes to infinity of 1 plus 1 over lambda n all the way to power n. So guys, I don't know if this one here was lambda, but what I saw was lambda. I don't know if here was 2, but if whatever uh what what was here is still the same thing. You can just simply replace it. So guys, in accordance with what we just proved, we saw that we could see this as a limit as n goes to infinity of 1 plus the 1 over lambda can go up. We have 1 over lambda all over n raised to the power. The coefficient of n here is 1, that is b, right? So in this case, our a is 1 over lambda, our b is 1, right? So this can just die down to e raised to the power ab. A is 1 over lambda, b is 1, so we're going to have e raised to the power 1 over lambda. Great. So guys, this is the limit. Let's look at the next example, which is the limit as n goes to infinity of 1 plus 1 over n raised to the power n over 2. So guys, to do this, all we have to do is simply to arrange it in the form that we can easily see it coming. We have n over 2 to be the same like 1 half n, right? Our a in this case is 1, our b is 1 half, so we're going to have e raised to the power 1 half, great, as the answer. Okay. Then now guys, let's look at the second proof, which is going to be the limit as x goes to infinity of 1 plus ax raised to the power b over x. Our goal is to show that it will simply die down to this again. So in this case, guys, at this point in time, similarly, we are going to let our y to be like the limit as x goes to infinity of 1 plus ax raised to the power b over x. So that taking the natural log on both sides, we have ln y to be like the limit as x goes to infinity of natural log of 1 plus ax raised to the power bx. Again, the log property tells us that we could bring the power to the front to have the ln y to be the same like the limit as x goes to infinity. B over x comes in form, we have b over x natural log of 1 plus ax. At this point, guys, let's arrange it such that we could see what is happening. We have the limit as x goes to 0 of b natural log of 1 plus ax all over x. Again, guys, L'Hopital's rule in action. Differentiate the top, we are just going to, if we differentiate the top, guys, we are just going to have, we have b's outside. Differentiate the top, that's natural log of 1 plus ax. We are going to have the denominator being 1 plus ax there. Then we multiply the numerator by the derivative of the inside, which is simply a. We have this. Of course, guys, differentiating x, we simply have 1. So this is what we have, guys. And when x goes to 0, guys, when x goes to 0, which is that what this part simply goes to where? To 0, right? So we are going to have just the natural log of y being equal to ab, means our y is therefore going to be e raised to the power ab. Therefore means that, guys, our y is given as what? The limit as n goes to infinity of 1 plus ax raised to the power b over x, right? So this is the same as we have the limit as x goes to 0 goes from 0 to goes to 0 of 1 plus ax raised to the power b over x has to be the same like e raised to the power ab. Okay, let's now look at the assignment that was given. They wanted us to evaluate the limit as x goes to 0 of 1 plus x raised to the power 2 over x. So we could arrange it as it being just e squared, okay? Because our a in this case is the coefficient of x, which is 1. Our b is 2, so we are going to have e raised to the power ab, which is simply e squared. Okay, let's take another example, guys. Although it wasn't asked, let's look at the limit as x goes to 0 of 1 minus 2x raised to the power of 2 over 5x. So friends, notice that we could arrange this as a limit as x goes to 0 of 1 plus we have negative 2x raised to the power 2 over 5 over x. So our a in this case is negative 2, our b is 2 over 5. Arranging it, guys, we are going to have an answer of e raised to the power negative 2 into 2 over 5. Simplifying that, guys, give us the limit to be the same as of this, guys, to be same like e raised to the power minus 4 over 5. Great. So guys, that is the end of our video. If there's something you don't understand, friends, let me know in the comment section down below. I'll make sure I reply you as soon as possible. Have a blessed day.